Alrighty guys, hey, what's going on? So for today, we're going to be talking about how to solve inequalities with variables on both sides. There's a couple steps to it. It's essentially the same as us solving regular equations. So if you take notice here, just our regular equations. However, we are changing out my equal sign for a inequality, which just means greater than, less than, or equal to, and things like that. But the steps are going to be ending up staying the same. So, way back when, I believe the acronym that we used was DCMAD. And that still applies here. So for the very first thing, we are going to either distribute or combine like terms. And that is going to be our first step, which takes care of the D and the C. The next thing is we are going to be moving our variables by collecting them on one side of our equation. Inequality. Next, we are going to be adding or subtracting, which is another way to collect our constants. And in this case, constant just means numbers. So constant or numbers on the other side of the inequality. And finally, the last thing is we most times are going to be dividing. However, this time we are going to be solving the inequality. Let me do purple again, solving. Now, there is a rule when it comes to solving, mostly when we are multiplying or dividing, and that is sometimes we have to flip the sign. So when we flip the sign is when we multiply or divide by a negative. And so you guys will see that here in a little bit. But again, what it means when we say flip is my greater than sign will then turn into, and vice versa, it can go either way, to a less than sign. So that's kind of what we mean by flip, is when the sign changes. So let's take a look at our very first problem here. It's looks like a 3-step problem, so it should be done in these 3. Step 1 was, again, to either distribute or combine like terms. Well, if I cut this right down the middle, it looks like there are no like terms on the left, and there's nothing to distribute. So my next step is going to be moving my x's to the left side. Well, in order to do that, I need to get rid of a positive 18x. So in order to get rid of positive 18, we subtract 18x on both sides. 21x minus 18x is going to give me 3x minus 9. These x's over here go away, and I'm left with 12. Then from here, we need to move my numbers to the other side, or move my constants to the other side. So how do I get rid of a negative 9? Well, we add 9 to both sides. From there, my negative 9 and positive 9 go away, and I'm left with 3x. 12 plus 9 is 21. And finally, our last step to solve this, we have 3 x's. Well, I only need 1. Well, again, something else too, this is 3 times x, so we are undoing this multiplication with division. And then the question becomes, are we dividing by a negative? And in this case, it's a positive 3, so my sign does not flip. So I'm going to take my original sign, which is greater than or equal to, drag it on down, and we get x is greater than or equal to whatever 21 divided by 3 is. I believe it's 7. And there we go. So again, guys, it's the same steps we were using when solving equations, but the difference is, equations, but the only difference is we are using inequalities. So greater than, less than, greater than or equal to. All right, next one, same thing. Gonna draw a line down my sign. And let's see, there is nothing to combine as well as no parentheses to distribute. So The very first thing is I want to move my x's to the other side. So I want to take my -9 and move it to the left by adding 9. Ooh, that's kind of hard to see. Adding 9. If I add 9x to the right, I need to add 9x to the left. My -9 and +9 go away. And -5x plus 9x is going to give me positive 4x plus 14. From there, my 2 falls down. The next thing I need to get rid of is I need to move my constant. So how do I get rid of a positive 14? By subtracting 14 on both sides. From there, positive 14 and -14 goes away, and I'm left with just 4x. 2 minus 14 is -12. Finally, my last step, this is 4 times x, which means I need to divide by 4 on both sides. 4 divided by 4 goes away, and I'm left with x. What I divided by is a positive 4. So because it's positive, there's no minus sign. My sign stays the same. So my greater than sign stays a greater than sign. -12 divided by 4, I believe, is -3. And there's my final answer. All right. Next one. One sec, guys. Okay. Next one. Let's take a look here. Again, same exact steps here. I'm going to go ahead and draw a line down my sign. For me, personally, I like moving my x's to the left side. I don't know. There's this... makes my life a little bit easier. So let's move this positive 3 to the other side by subtracting, 3x, not just 3. So I'm subtracting 3x on both sides. 3x and 3x over here goes away. And let's see, so 25 falls down. -7x minus 3x gives me -10x. So again, these are similar terms. Okay, next thing. Sorry, guys. So, next thing I want to talk about is my 50's going to drop down, and so it's going to be positive 50. All right. Now, from there, I need to get my numbers to the other side. This is a positive 25, so I'm going to subtract 25 on the left, which means I subtract 25 on the right. 25 goes away, and I'm left with -10x. And 50 minus 25, I believe, is just 25. All right, my final step, this is -10 times x, which means I need to undo it by dividing. And this time, I'm dividing by -10. Whoa, -10. Okay, I am dividing by a negative here. Let's make a little note to ourselves. We divide by a negative, which again means that I have to flip my sign. So my less than or equal to sign is going to become a greater than or equal to sign. Okay, now let's continue on with our problem. -10 divided by -10 is just x. 25 divided by -10 is going to be some fraction. I believe it's just going to be -5/2. And there we go. So again, we get a fraction here, which is not the prettiest, but sometimes, well, that's what we get. All right. So let's continue on. Let's keep talking about how we're going to be solving. It looks like we kind of up the difficulty here by adding some parentheses. But again, guys, don't be afraid of these. We know how to save some drowning babies. So again, remember, my lifeguard is going to jump in and save these numbers here. 2 times -3x is -6x. 2 times 1 is +2. Is less than -5x plus 14. All right, now we are ready to solve. So let me put my line down my sign once again. And again, I'm moving my x's over to the left. It just makes my life easier. So I'm going to get rid of this negative 5x by adding 5x to both sides. From there, negative 5x and 5x goes away. Negative 6x plus 5x is negative x. Plus 2 falls down, and my 14 also falls down. From there, I need to get rid of this positive 2, so I'm going to subtract 2 on both sides. And from there, my negative 2 and positive 2 goes away, and I'm left with negative x. And 14 minus 2 is 12. Final step here. Technically, this is a negative 1x, and so what we're going to divide by this time is a negative 1. Negative 1 divided by negative. Again, guys, if we divide by a negative, something happens. Remember, I need these alarms to go off into your head because that will change your answer. Negative divided by a negative goes away, and my sign is going to flip into a greater than sign. So my less than sign now becomes a greater than sign. And that's, of course, when we divide by a negative. Finally, 12 divided by negative 1 is just negative 12. All right. Let's keep rocking and rolling, guys. Oh, wait a minute. I forgot all this extra stuff. Okay, so it wants us to check our answer. And essentially what that means is we are going to see if this solution, remember, these are a solution inequality, and we want to check that. Okay, well, we need a number that is greater than negative 12. Okay, well, let's see what that's going to look like. So I'm going to make my center dot here at negative 12, and let's think about my number line. So if I go in the right direction, I get these numbers here. So negative 11, negative 10, negative 9, negative 8, negative 7, so on and so forth. And if I go in the left direction, my numbers seem to get bigger. So I get negative 13, negative 14, negative 15, so on and so forth. Okay, well, here is where my first dot is going. That's my reference point at negative 12. Notice this inequality is a greater than sign. And so if it's greater than, are we going to be shading to the left where my numbers look like they're kind of getting bigger, or are we going to be shading to the right? And guys, in this case, we are going to the right. Now, again, the reason for it is when my numbers are increasing, well, negative 10 and negative 12, negative 10 is my bigger number. It's better to owe someone $10 than it is to owe someone $12. Okay, so now that we know that I need numbers that are greater than negative 12, so we're going to the right, what is a number that I think of that is bigger than, well, that's a number over here. Well, the easiest number that I can think of is when x is equal to 0. 0 is bigger than negative 12, so this should, in fact, work. So let's go ahead, let's take my equation, and let's replace all of my x's with a 0. So let's see what that's going to look like. So it's going to be 2 parentheses, negative 3x plus 1 is less than negative 5x plus 14. Okay, again, I'm replacing these x's with zeros. Let's see what that's going to look like. 2 parentheses. Negative 3 times x is negative 3 times 0 plus 1. It's less than. Negative 5 times x is negative 5 times 0 plus 14. Okay, let's take a look. From here, let's see if we can simplify some things. Anything times 0 is, well, 0. Okay, so that means we are left with 2 times, well, 0 plus, so 0 plus 1 is just 1, is less than, and again, anything times 0 is 0, so we can ignore this, and I'm left with a 14. Okay, 2 times 1 is 2, is less than 14. This is a true statement. So we can say that this, in fact, is true, which means that my answer is correct. Yay, we did it. All right, let's try another. Okay, number 2. Again, we have parentheses, which means I have to distribute. And in this case, my lifeguard is actually going to be a ninja 1. He's a 1 that's there, but he's not really there. And let's go ahead and distribute here and see how that's going to affect my problem. So on the right-hand side, -1 times x is negative x. -1 times negative is a positive 41. Okay, on the left side, well, nothing really good happens over here. So it's just the same. All right, now we are ready to solve this. So let me draw a line down my side, and let's take a look how this problem is going to work. Remember, first thing I want to do is move my x's. So I'm going to get rid of this negative x with a positive x. Technically, this is a 1x right here. So 9x plus 1x is 10x. My 19 falls down. That's a positive 10. Over here, my negative 1x and positive 1x goes away, and I'm left with just a 41. Okay, next I need to move my 19 to the other side. So this is a positive 19, so I'm going to subtract 19 on the left and subtract 19 on the right. 19 and 19 go away, and I'm left with 10x. 41 minus 19. Ooh, that's kind of a tricky one. Okay, hang on. That's going to be 2 and looks to be 22. Hope I got that right. Okay, now from there, guys, my last step, again, this is 10 times x, which means I need to undo this multiplication by dividing by a positive 10. So not like our last one where we divided by a negative. This time it's a positive, and we get x is equal to, not equal to, x is less than or equal to, so less than or equal to, so my sign does not change. 22 divided by 10, oh gosh, I believe 11 over 5. Yeah, it's a positive 11 over 5. Okay, sweet. My number line's gonna look crazy looking at this. Okay, so let's take a look. X needs to be less than or equal to 11/5. Okay, well, let's do this. So 11/5 is where we start. A number that is less than that is, well, gonna be 10/5. 9/5. I can keep going. 8/5, 7/5, and 6/5. So this is going in the down direction, if you will. And on the opposite side, 12/5, 13/5, 14/5, 15/5. Oh, there are some whole numbers here. If you take a look, we could actually simplify. 15/5 is, I believe, just 3. 15 divided by 5. 10 divided by 5 is 2. And we would have a 1 a little bit further down my number line. Okay, but the value that we were focusing on is 11/5. So let's draw a circle here. Now, something that I want to say is, check this out. This is a less than or equal to sign. This sign, let me go ahead and put a box around it. This sign has a solid line underneath it. This solid line means I need to use a solid circle. So, again, a solid line, a solid circle. Over here, we just had a greater than sign. So a greater than sign did not have a solid line, so it was an open circle. A less than or equal to sign has a solid line, so a solid circle. And I can kind of use this as a reference. So I need the numbers that are less than 11/5. Well, that ends up being all these numbers over here on the left. And if you notice, I'm going down my number line. We said that this was 3, this was 2, 1 would be over here, and technically 0 would also fall into this realm. So again, we can check with another pretty easy number. So x equals 0. Let's check this guy out and see if this works. Okay, here is my formula that we are going to plug this into. So 19 plus 9x is less than or equal to negative parentheses x minus 41. Alrighty, and then again, we are going to be replacing these x's with 0. So let's take a look. 19 plus 9 times x becomes 9 times 0 is less than or equal to negative parentheses x minus 41 becomes 0 minus 41. And let's take a look here. Anything times 0 is just, well, 0, so that goes away. And I'm left with 19 is less than or equal to 0 minus 41 is going to give me negative 41. And something pretty interesting happens here, guys. We have a negative times a negative, which turns this into, because technically this is negative 1 times negative 41, and that's going to give me a positive 41. And let's see, is 19 less than or equal to 41? And in this case, it is. So this holds true. Sorry about that train there, guys. I don't know if you heard it or not, but I do apologize. I'm filming in a different location today. Okay, but again, we are able to check by using a number. I would recommend an easy number for whenever you do these calculations and for whenever you're checking. If 0 is an option, that's going to be the easiest number that you can use. Let's see how this next example works out. I hope we can use 0 again, but I don't know. Let's find out. Okay, number 3. So again, first things first, let's get rid of these parentheses. Negative 4 times 3 is negative 12. Negative 4 times positive 3 is going to be 12x. Excuse me, negative 12x. Woo! Sorry, guys. Over here on the right side. Whoa, don't forget my greater than sign. Over here on the right side, same thing. So 6 times 4 is 24. 6 times negative x is, well, negative 6x. Again, my first step is to move my x's to the other side. So I'm going to add 6x to both sides. And let me draw a line down my sign so I can keep things organized. All right, negative 12 just falls down, nothing really to it. So negative 12 falls down. Negative 12x plus 6, these are different signs, so we subtract those and we get negative 6x. And 24 falls down. From here, negative 6 plus 6 goes away, and I get 0. Or I can just cross those out. From there, I need to get rid of this negative 12 on this side by adding 12 to both sides. Negative 12 plus 12 goes away, and what I get is negative 6x equals, well, not equals, technically it's still a greater than sign, but 24 plus 12 is, I believe, 36. Oh, and this works out pretty nicely. So let's take a look. Again, we have negative 6x times, negative 6 times x. We need to undo that multiplication by dividing by negative 6. Whoa, whoa, whoa. Hey guys, again, we are dividing by a negative. Oh man, you guys probably definitely heard that one. Again, when we divide by a negative, be careful. That means that my greater than sign is going to turn into a less than sign. Negative 6 divided by negative 6 goes away, and I'm left with x is less than. Again, we flip that sign. 36 divided by negative 6 is going to be negative 6. Alrighty, so let's take a look. Let's see if we can visualize what this is going to look like. Again, we are using a less than sign, which means it's going to be a open circle. The value that I'm focusing on this time is negative 6. And my number line going to the left this direction is going to be all these numbers. Again, if we go in the opposite direction, we are getting bigger. So negative 5, negative 4, negative 3, negative 2, negative 1. And we are going to the less than direction. So again, guys, something I want to say, we have a less than sign, which means I need numbers to be less than negative 6, which tells me we're going to the left. An easy number this time is not really existent. Unfortunately, 0 is not going to be a number that we can check with this time. So let's use, I don't know, I kind of like 10s. 10s are pretty easy to multiply by. So let's check if x is equal to negative 10. Let's see what happens. Hopefully nothing too crazy. All right, let's take a look. So negative 4, parentheses 3. So let me rewrite this here. So negative 4, parentheses 3 plus 3 times x is greater than 6, parentheses 4 minus x. Okay, so we are replacing these x's with a negative 10. Let's see what that's going to look like. Negative 4, parentheses 3 plus 3 times negative 10. So again, 3 times x turns into 3 times negative 10 is greater than 6, parentheses 4 minus negative x, 4 minus negative 10. Okay, so let's simplify this. I think I forgot a parenthesis over here. Okay, all right, let's take a look at this. So let's work inside first. So 3 times negative 10 is going to be 3 minus 30. Over here, 4 minus 10 is going to turn into 4 plus 10, which gives me 14. So we have 6 times 14 on the right. And let me split this up. 3 minus 30, this is still inside of parentheses. 3 minus 30 is going to be negative 27. And so we have negative 4, which just falls down here. So negative 4 times negative 27 and 6 times 14. Let's see which one's the bigger number. I have my bets on the left side, but let's find out. Negative 4 times negative 27 is going to give us 4 times 7 is 28 times 4, 18, carry 108. And a negative times a negative is a positive. Over here, 6 times 14 is, well, let's see, 6 times 4 is 24. 6 times that is 6, 84. All right, which one is bigger, the 108 or the 84? It is the 108. There we go. So this ends up working. So my solution of my x values are less than negative 6. And this works. This works for us. Let's put a box around my solution here. There we go. Alrighty, guys.
Alright, so let's continue with where we, on the back side. For this piece here, again, I want to see if we have any like terms to combine or anything to distribute. It looks like we don't. So again, my first step is moving my x's to the other side. So I'm going to subtract 29.7x on the right, which means I subtract 29.7x on the left. These go away, and I'm left with 55.2 minus 29.7, which equals 25.5 x. My minus 75 drops down, and my 52.5 also drops down. Now I need to move my numbers to the other side, so I'm going to add a 75 to both sides. 75 goes away, and I'm left with 25.5x. And 52.5 plus 75 is 127.5. Lastly, this is 25.5 times x, which means we need to divide by 25.5 on both sides. From here I get x is equal to, not equal to, greater than 127.5 divided by 25.5 is 5. And there we go. Alright, let's try another. Okay. So this one has distribution on it. So again, let's get rid of these parentheses by distributing. I'm going to draw a line down my sign. And let's see what we're going to get. So negative 3 times 3 is 9x. Negative 3 times positive 1 is negative 3. And we said this is negative 9x, excuse me. And my 22 just falls down. On the right side, nothing interesting happens. Okay, now next step is either combine like terms, or we can start moving my x's. I'm going to move my x first, just because, I don't know, I like to go ahead and take care of that right now. So negative x and positive x goes away, and I'm left with 44. Over here, this is a negative 9 plus x, and this is going to give me negative 8x. My minus 3 falls down, and my 22 falls down. Okay, next I need to move my numbers. So to get rid of a negative 3, I'm going to add 3 to both sides. To get rid of a positive 22, I'm going to subtract 22 on both sides. And check it out. My 22 and 22 go away. Negative 3 and positive 3 go away. And what I'm left with is negative 8x. Let me make my line a little bit longer. And now these numbers, I can go ahead and combine these. These are also combining like terms. So it's 44 plus 3 minus 22 gives me 25. Whoa. Hang on, guys. Sorry. My 4 magically became a, my 5 magically became a 4. So this should be 45. This should be a 45. And that means that my answer should be 26. Okay. Okay, now last step. Again, we divide everything by negative 8. And I get x is, whoa! What did we just divide by? Again, when you divide by a negative, I hope an alarm or something goes off in your head, because that means that my greater than sign is now going to become a less than sign. And in this case, less than or equal to. 26 divided by 8 is just going to be some fraction. I think it's going to be 13 over negative 4 is what that simplifies to. And there we go. There we go. There we go. Number 6, I'm going to skip for time purposes. Let's go ahead and let's take a look at number 7. Preston is playing a game where he must solve the inequality below and then throw a dart at a board. If the dart lands on a square with the value that is a solution, he wins. So we want to shade in any square that Preston could land on. Okay, so it's just asking us which of these numbers is a solution. All right, well, let's draw a line down my sign. Again, first thing we got to do is we need to distribute to get rid of these parentheses. 5 times 4 is 20. 5 times negative x is negative 5x. 2 times negative 4 is negative 8. 2 times 7 is positive 14. From there, again, I move my x's first. So I add 8x to both sides. 8x and 8x goes away. And what I'm left with now is 20 plus 3x. 14 falls down. All right, now from there, I need to get rid of this 20 here. So that's a positive 20. I subtract 20 on both sides. Let me make my line a little bit longer here. 20 minus 20 goes away, and I'm left with 3x. 14 minus 20 is going to be negative 6. And let's divide at the end. So I divide by 3. From there, I get x is equal to negative 6 divided by 3 is 2, negative 2. And then I said equal to, I'm sorry, guys, greater than negative 2. X is greater than negative 2. And on a number line, I'm just going to do a rough number line real fast. So here's negative 2. We have a open circle, and we shade to the right. So let's see. Numbers that are greater than negative 2. Well, that looks to be, so 10 is a number greater than negative 2. 0 is also a number. 4 and 6, essentially anything positive is going to be greater than negative 2. Okay, now let's take a look at these negative numbers. Negative 12 is way over here. So negative 12 on my number line does not. Negative 3 would be here. Negative 5. Negative 1 would be, I believe, my last one. Okay, there we go. So those numbers are numbers that Preston could land on. Those are valuable solutions. All right, let's do one more of these guys, and then we'll call it a day. Okay, so Jan needs to buy a backpack and several folders for school. If she shops at Smart Supply, the backpack costs about $45. Folders are 45 cents each. If she shops at the Supply Guys, backpacks are $50.40, and folders cost around $15 each. Write and solve inequality to find the number of folders Jan will need to buy for the Supply Guys to be the cheaper option. Okay, so let's take a look. So she needs the Supply Guys to be the cheaper option, and we need to write an equation. So 45 cents each. This little each right here, guys, is a key word to letting me know this is where my variable is going. So in this case, we're talking about folders. So X will be folders. And so the Smart Supply backpack. So Smart Supply, it's going to cost us $45 plus 45 cents each. So this is for the Smart Supply. All right. And then the Supply Guys, that's costing me $50.40 plus, this is 15 cents a piece, so 0.15x. So here is the equation for the smart supply. Here is the equation for the supply guys. And we need the supply guys to be the cheaper option, which means that the smart supply, so this is smart supply, is going to be greater than the supply guys. All right. And then from here, we are just solving. So again, first step, move my x's. So minus 0.15, x to both sides. From there, 15x, 0.15x minus 0.15x goes away. And I'm left with 0.30x. I'm going to draw a line down my sign here, just to keep things organized. And my 45 falls down, and my 50.40 falls down. From there, I need to get rid of this positive 45 by subtracting 45. So minus 45 on both sides. And 45 and 45 goes away, and I'm left with 0.30x. And 50 minus, give me one sec, 50.40 minus 45 is 5.4. All right, last step is we need to divide both of these by 0.30. And we are not dividing by a negative here, so that means we do not have to flip my sign. So let's see, divided by 0.3 is going to give me 18. So, again, x is greater than 18 in this case. And there is my solution. We could plug this in if we wanted to double check, but I don't want us to run out of time here. Alrighty, guys. I think that's going to be it for our day for today. I hope you guys have a great rest of your day, and I'll see you next time.